Very good morning everyone. Today my topic in electrochemistry is galvanic cell. I have already done in previous class what is galvanic cell. Already you know the galvanic cell or voltaic cell or Daniel cell all work on the same principle or mechanism. What is that? What is the definition of the galvanic cell? Dear students, a system or device which is used to convert chemical energy into electrical energy as a result of indirect redox reaction is called electrochemical cell or galvanic cell. See, in this process reaction is spontaneous because of indirect redox reaction takes place. Why is it so called indirect redox reaction? Because two different beakers are connected by galvanometer and two electrodes are connected by the galvanometer and the two beakers are connected by the salt bridge. Salt bridge is actually a inverted U-shaped glass rod apparatus in which inert electrolytes are kept. This is one beaker containing negative pole which is made by the zinc rod, that is anode, where you can say, dear students, what takes place here? Oxidation takes place. On the other side, it is the positive electrode that is made by the copper, and where it is called cathode, and where what takes place? Reduction takes place. Important point is these two beakers are connected by the salt bridge and two electrodes are connected by the galvanometer. The flow of electron, you always keep in mind, right? That is from anode to cathode. Negative pole to positive pole, because the electron flows, current flows opposite to the direction of the electron. It is the conventional current flows from cathode to the anode, but the electron flows from anode to the cathode. And here it is the zinc sulfate solution, and here it is the copper sulfate solution. So in this process, the mechanism of this process is called, when the zinc loses electron, the concentration of positive charge increases in the left hand side. More the tendency to lose electron, more the positive charge, more the concentration of the zinc electrode here increases, and the electron is going to be deposited to the other side, where the concentration of negative charge is increasing. As such, the function of salt bridge is to maintain the electrical neutrality. Positive charge is neutralized by the supply of the charge from the salt bridge to the negative, and the negative charge is cancelled out to the positive. The way electrochemical cell or galvanic cell works on this principle. See, dear students, on the basis of that, see what the reaction in this process. So net redox reaction in this process, as you know, zinc is more reactive than copper. So the reaction involved in this process is zinc solid, copper 2 positive aqueous, that is the zinc 2 positive aqueous plus copper, what is that? Solid. See, zinc is oxidized here, it is, and the copper ion is, what is that? Copper ion is reduced because it is done in the redox reaction, increase in positive charge oxidation and decrease in positive charge reduction. So the net reaction is Zn solid, that is zinc 2 positive, 2 electron lost. What is this? This is oxidation, and copper 2 positive aqueous gaining 2 electron, copper solid and zinc aqueous. It is, what is that? Reduction. So net redox reaction is zinc solid plus copper 2 positive aqueous, that gives zinc 2 positive aqueous plus copper, what is there? Copper is solid. So the cell reaction is, what is the cell reaction? zinc solid oblique zinc 2 positive aqueous, that is divided by the salt bridge, and this is the electrode couple, where what does it take place? It is oxidation and copper to aqueous and copper solid. What is this? Reduction takes place. These two electrodes are divided by or separated by galvanometer. That is, students, here on the basis of that you can calculate EMF, electromotive force, or E naught cell, that is the standard electrode at cathode minus standard electrode at what? Anode. What does it take place at the cathode? Cathode, the reduction takes place, and the anode, what is this? Oxidation takes place. Therefore, this is the E naught is the right side written, and then it is left side here. Oxidation taking place in the left side and reduction takes place in the right side, just to go at a glance in the galvanic cell. There already I have mentioned it. So reduction minus oxidation, right minus left, or higher potential minus, what is that? Lower potential. You have done that is the, you see, electrochemical series, right? The increasing order of the reduction potential or decreasing order of the oxidation potential. So we don't repeat this time the electrochemical series. We have already done in the previous class. So keep in mind. So the way you can calculate E naught cell. If E naught cell is found to be positive, then the reaction is feasible. If E naught cell is, what is that? Positive, then reaction is spontaneous and, what is that? Feasible. If E naught cell is found to be negative, then it is, what is that? Infeasible. So far as galvanic cell is concerned, here, see, keep this EMF, this is the difference between electrode potential at cathode minus electrode potential at anode. Therefore, you can calculate the E cell equal to reduction takes place, that is the copper ion, copper 2 positive oblique copper minus E naught oxidation zinc 2 positive. Therefore, here you remember the value of zinc and copper, that is the electrochemical series. In numerical, that value already will be given. So here 0.34 volt minus 0.67 volt, that is what? So it is 1.10 volt. How much the current is produced from the galvanic cell? Approximately 1.1 volt. On the basis of that, we can calculate Gibbs free energy. We have done in thermodynamics in previous class. What is Gibbs free energy? Delta naught G is equal to minus NF E naught cell. What is N? Number of moles of electrons, where N is the number of moles of electron lost or gained during the redox reaction. And what is F? The student, F is the Faraday's constant, and the value of F is how much here? 96500 coulomb. How do you get these values? That is the charge of electron multiplied by the Avogadro number. On the basis of that, we can calculate Faraday's constant. And what is the E naught cell? This time, mean short while we have calculated E naught cell, E cathode minus E anode. In numerical section, sometimes this value is given. If not, then you can calculate E cathode minus E anode. Reduction minus oxidation, high potential minus lower potential. The way we can calculate E naught cell. So far as galvanic cell is concerned, tell me anybody, what is the Gibbs free energy here? Gibbs free energy of the galvanic cell is minus 2 into 96500 into 1.10 volt. So the way delta gives energy, whatever the value is calculated, that is the energy in the joule. Once you divide it by 1000, it will be in, what is that? Kilojoule. So I hope if question comes in your paper, explain galvanic cell and also explain in brief the construction and function of the galvanic cell and the reaction involved in it. This is all about electrochemical cell or